This will round out chapter 2, so we're going to finish off with taking and working with solving absolute value inequalities. So the big thing that we need to know, and I'm going to put at the top of our notes here, and our notes are on page 56 in your note packet, we're going to talk about and or. As you noticed, the inequality is what the most important thing was. Ands are going to be the less than or less than and equal to. Ors are going to be the greater than or greater than and equal to signs. So if you have those in the problem, you need to pay attention. One of them is going to be a compound or graphing together one. The other one is going to be an or, which means they're going to graph away from each other. Now we have two other special ones, but we're really not going to get into those. We have, like I said, a few special ones, but for the majority of them, we're going to try to stay with what we know. So the first thing that we look at here when we're doing this is going to be the inequality sign. So look at number 1. We have a less than sign. So if we look back up at our little chart, we know that and is going to be what we're going to have here. We learned in chapter 1 that inequalities are wrote in two separate ones, one positive, one negative. We also learned that the y has to be isolated, and then the inequality here also, so the absolute value has to be isolated on one side and everything on the other side. We're solving for y again. So kind of everything we did in chapter 1 towards the end, we're just tying into inequalities. So we're going to have y plus 2 is less than 8. Now here is the difference. It's going to be y plus 2 is greater than negative 8. This is the change that you have from chapter 1 to chapter 2. So your absolute value still has one positive, one negative, but the inequality sign on the second one has to flip also, not just the sign, but the inequality sign. So we're going to take and solve these. So I subtract 2 on both sides, so y is less than 6. And over here, we know y is greater than negative 10. Now, we have to write it as a compound to finish for our answer. Well, we know negative 10 is the smallest, y goes in the middle, and 6 goes on the end. Let's look at our inequality signs. We know that they are greater than and less than. So y, it says over here, is less than 6. And here we know y is greater. So to make it greater, you have to put it open towards the y. So now that we've got the compound statement written, let's graph it. So this one we're probably going to run out of room, so let's do a multiples of 2. So if this is 0, this right here should have been 0. This is going to be 2, 4, 6. This is negative 2, negative 4, negative 6, negative 8, and negative 10. They are both open circles because of the original sign that we had, and we're going to graph them towards each other. So this is what it should look like. All right, so now let's look at number 2. Number 2 is an or statement. So in this particular one, we are going to have Q divided by 3 is greater than 2, or Q divided by 3 is less than negative 2. So I know when I write this, we're going to have an or statement. So you have two different Q answers. We know we have to clear the fraction by multiplying by 3 to get it out of the denominator. So when you do that, Q is going to be greater than 6, or Q is going to be less than negative 6. So Q is greater than 6, and Q is less than negative 6. All right, so that one wasn't as difficult as the first one to write. So now we're going to take and graph it. I'm going to use multiples of 2 again. So 2, 4, 6, 2, 4, and 6 in the negative. So I'm going to put my open circles because they are both that way. Now it says Q is greater than that, so we're going to shade right. And this one said Q is less than that, so we're going to shade left. Okay, so 1 and 2, not so bad. Now we're going to start getting into some of the trick ones. And I say trick being that they're going to want you to follow through and do a few steps. And I want you to be real careful with these because you can fall into traps. So the first thing we're going to do here is actually take and get it isolated, the absolute value. So I'm going to subtract 10 across the equals or the inequality sign. So I have 3 absolute value, 2a plus 5 is less than or equal to 27. Now, let's make life a little simpler. So if we're going to do that, let's take and write them out. So this is going to be 3 parentheses, 2a plus 5 is less than or equal to 27. And since this is a less than symbol, we know this is an and. So I know when I get done, I'm going to have to write them all in one compound statement. So this is going to be 3 parentheses 2a plus 5. We're going to flip the inequality sign and flip the sign. All right, I'm going to divide this by 3. So I get 2a plus 5 is less than or equal to 9, and 2a plus 5 is greater than or equal to negative 9. Now I'm going to take and I am going to add or subtract 5 since it's being added. So I have 2a is less than or equal to 14. And this one here, we're going to subtract 5 across. And that right there should have been subtracted. I should have been 4 to begin with. And then this one here is going to be 2a is greater than or equal to negative 14. So what I have for my two answers is I'm going to have 2 divided into 4, which should have been 4 to begin with, not 14. This right here is going to make a 2. I have my a here, and this is going to be negative 7. So apologize for the mess there. If I had a little white out, it'd probably help. This is going to be negative 7 is, in this case, less than or equal to a, and 2 is going to be also greater than or equal to or less than or equal to from the a to the other side. So let's graph these two. So what I have here is I'm going to be using multiples of 2. So there's 0. So this is 2. This is negative 2, negative 4, negative 6, negative 8. I am right here in the middle. It is a closed circle for both of them. And since this is an and, they're going towards each other. All right, now I want you to try number 4. So try number 4 on your own. And when you come back on, then the answer should be there. But try it on your own, pause the video. Okay, so looking at number 4, did you get that? So you broke them into 2 separates. Y minus 3 is less than or equal to 4, and y minus 3 is greater than or equal to negative 4. So you should have gotten negative 1 and 7. So when we put these in, we wrote it as a compound because the original statement is an and statement. And then when we graphed it, then we knew we were shading towards each other. And that's something that's big. If you know it's an and statement, you know you are shading towards each other. If it's an or statement, you know you're going away from each other. All right, so here's number 5. I went ahead and started it. So I want you to look at number 5 now. It's the same concept. We had to add the 4 across first before we broke it into the 2 separates because we had to isolate the absolute value. So take a moment. I'm going to pause the video and I want you to finish it and then. All right, so did you complete it on your own without cheating? I hope you did. All right, let's go through this. We have 0 here. And negative 7 is going to land right here. They are both open circles. And once again, this one is an and statement as well. So your and statement for this one is quite easy to pick out. This is not one of the special cases. So this whole page hasn't been any special cases. Now we're going to shade in between and we're good to go. All right, so if you need to see those two again, pause it, go back, figure it out. We're now going to move on through 6 through 10, and that will finish this video. Okay, so now we're getting into some of the specials here. And when I talk about specials, what I'm talking about is how we need to know some things. First off, we know absolute values cannot be equal to negative numbers. However, if it happens, there's something special that happens. This is normally an or statement, okay? So if that inequality has an absolute value with an or statement on it, then we know that this particular one is going to be called an all real numbers. We know this because it is set equal to a -4 or an absolute value of -4. In this case, this was an and. And statements are supposed to be shading towards each other. What happens is when you do this particular problem, they end up behaving like an or statement, so they have no solutions whatsoever. So that's why this is going to be a no solution. Now, you do not have to solve those problems. All you have to do is remember what it looks like or the setup. If there's a negative number on the right to begin with, and you have no number that's going to come across and get rid of it, like getting it across and making it become positive, then what's going to happen is you are going to look at the setup, and if it's an or statement, it's an all real, and if it's an and statement, it's a no solution. All right, so take a minute, absorb that, pause the video if you need to. Let's go on to number 8 if you are done pausing the video. This one, it would be basically just working it out. So all I'm going to do here is isolate that absolute value first. So I take and move this across by subtracting 8, and I get 9. So now I have two absolute values again. So I'm going to have 4x minus 7 is greater than or equal to 9, and 4x minus 7 is less than or equal to -9. Now, see how this right here is like that? So we know it's going to be an or statement. All right, so we know it's an or statement because it is a greater than or equal to. So go ahead and solve. I add 7 across, so I get 4x is greater than or equal to 16, or x is greater than or equal to 4. Add 7 over here, and I'm going to get 4x is less than or equal to -2, or x is less than or equal to -1/2. If you didn't see where the 1/2 came from, 2 over 4 reduces to 1/2. So remember, these are or statements. So you're going to leave them exactly like they are and graph each one individually. So I know here, this is 0. This right here, let's make 1. Over here, actually, let's make that just -2. Over here, we have 1, 2, 3, and 4. We know that x is greater than that, so I'm going to shade it in, and it's going to go to the right. For this one here, it's at 1/2, so I'm going to shade it in, and I know this one's going to go to the left. And that's all she wrote on that, folks. There's nothing else you can do with that one. Number 9 actually is very easy to do because of a couple reasons. One of them is when I subtract the 14 across, I'm going to get a single answer in this case, okay? Watch what happens. This becomes 6 absolute value, 3 minus k is greater than 0. So I have, if you divide this across, this is actually going to be 6 divided into 0, which is 0. So this is 3 minus k is greater than 0, and 3 minus k is less than 0. So what you're going to have here is you're going to end up with, if you move the k across, 3 is greater than k, or 3 is less than k. So the other way to write this, of course, is k is less than 3, or k is greater than 3. So that basically is what I'm looking for. And what this is doing, watch this, this is so cool. You do not get what you expect. This is not all real numbers. This is actually, everything works except for 3. Since this is a greater than or less than, and there's no equal to, Now, if there had been an equal to, this entire thing would have not, conversation would not have happened. You would have just said all real numbers. But since this is just a greater than to start out with, that means that I have an open circle. That means everything works under the sun and moon and stars except for 3, which is pretty cool. All right, last one. This is the story problem on the bottom. At a certain company, the average starting salary for a new worker is $25,000. Okay, so $25,000 is our startup. All right, so we have that. The actual salary has an absolute value deviation of at most 1,800. So believe it or not, when you talk about standard deviation, which we don't talk about a lot yet, this is what I'm going to be. And at most means that that is the greatest end of deviation you got. So to find the real salary, you're going to say salary minus, because if that's your starting, you can only get bigger. Okay, so they're going to start you either at 25,000 or 1,800 above it or 1,800 below it is what they're saying. So to get that set up, we have to first say, okay, 25,000, the S minus that means that I'm taking and setting it up. If this had been an equal to sign, you would have subtracted and got it, but I want to know the upper limit and the lower limit. So that's what we're writing as an inequality. So here's our upper limit. S minus 25,000, which is less than or equal to 1,800. So if I add that across, that means the highest I can go is 26,800. Now, if we wrote it the other way, S minus 25,000 is greater than or equal to negative 1,800, that means I'm going to be subtracting it. So S is less than or equal to 23,200. So that means that I have a lower limit of 23,200. That's the lowest I can go. And my highest I can go starting out there is 26,800. Okay, now take a moment, go back through it. By the way, this would be your final answer. This right here is your setup. So setup, answer. Make sure that you can identify that. Make sure that you can write that and set them up. Folks, you've been great. This is our last video. It is a little more complex. You may have to watch it more than once, but get your homework done right away so you don't lose what you've learned. Have a good evening.